Thank you.
But it's a special lecture that it's like.
Okay, so let's have a class. First of all, what we did on Tuesday. Did on Tuesday is you pathogenic fungi. But what's more important is we say it's a indicator bacteria in pond water. So we had a petrofilm. So petrofilm is like this. Okay, first thing. Lots of user results looks like this. A circle there. Some of your results like this. What's the problem? The volume. How many we should add onto the petrofilm? And some of you did a good job. 1 ml equals 1,000 microliter. But lots of you add 100 microliter.
I told them to do that.
Yeah. That's what I said. That looks this results looks weird. So this is give you some experiences in the future. When you ever work in some places, when you see the petrofilm who did it like that, the volume is incorrect. You add 100 microliter. Now what is the correct? There is some people right here did it really good. So we want to do this one. I'll just follow these, okay? These are good example. What it looks like. Is that right? That looks good. That looks good. And this one looks good. Now what mine looks like, I have one example right here because I didn't throw them away. No, mine looks good too. Looks like that. So this is the first thing. It's very important for the petrofilm. But lots of people didn't recognize it. When you see a small dots there, the volume is incorrect. Okay, now let's talk a second question. It doesn't matter how you do. You can see the results. Lots of you will see a red dots. What's that? The red one is coliform. But you can see some of you have a very good results. Look at the 32. There is a gas bubble there and with blue dots. That is E. coli. I have another good example here, right here. Although the volume is not correct, but looks good for E. coli. That is E. coli. Although the volume is incorrect, but looks good. Yeah. So I will be returning these back. So number 32, who is number 32? So she did a really good job. Yes, you can see the E. coli there, and the coliform are completely different, and you can see a lot of coliform. It's really nice job. Number 31 also did a good job, although there is no E. coli, but we see the coliform is very good. Okay. So that means I have to be emphasized to you. What is E. coli? You cannot see it. This is very important. Lots of people don't recognize it. Gas packed blue colony. This is E. coli. I would say generic E. coli. And this one you add up together is coliform, and we don't always say coliform, we say total coliform. Okay, this is important, that's why we want to review. And these we'll just put on the side. What we're gonna do today? We're gonna do analysis of bacteria in food. In foods. This will be lab, I think lab 16. Okay. We will talk about the preparation, how we're going to do. Then the numeration and the calculation we'll talk about on Tuesday when we do the review session. This will be chunk of the question in the final exam. So first of all, let's talk about all these different products. We got a cherry tomato. Okay, that's come from greenhouse. I think it's very small. We got a chicken, a bird's carcasses. We get hot dog, and we get a ground beef. So we're gonna do the process of how we do the analyze. What we are here to do is a general total microorganism. Okay, it's not specific for pathogen because we are not allowed to isolation pathogen. So first thing first, let's talk about tomato. So tomato, when you see it like this, we really care about the pathogen is Salmonella. Salmonella spp. That's Salmonella enterica, subspecies enterica is a foodborne pathogen. There are lots of outbreaks, recalls. Tomato have the area, which is right there, called stain scar. This area could hiding a lots of bacteria. So you see that right here, the middle inside is stain scar. That's lots of bacteria could hiding. There is some research what they do. They are using laser confocal microscope to see how they penetrate inside with like the staining, like a Davy stain when we talk about in the lecture. So lots of the research but done those things. So Salmonella is a risk. Tomato, the big production is coming from Florida, and they also coming from Yuma, Arizona. Those are the two places generate about 80% of the total tomato production in the U.S. West Virginia basically is a high tunnel. Okay, it's a more localized. So tomato, how are we going to do the sample? We are adding a tomato into a bag. We will add 50 ml, 0.1% nutrient broth. Okay, let's do that. I need gloves, so I wear gloves. Got a medium-sized gloves. Because the processing of these sample is very unique, and it's very important we get to know how we do it. So we have a tomato, and we have a cylinder. We're going to add 50 ml. So how we do, this is called a food sampling bag, the well pack. So we're going to do like this, tear it off, and then you have a link. Okay, make sure it's a little bit large. Then you put a tomato inside. When you put the tomato inside, we want to discharge the bacteria from the surface into the solution. We have to add the solution. So we add a 50 ml. Just use a cylinder. This cylinder is autoclaved. So we added. Okay, when we added, what we do? Usually we back cover it. We're doing like this. We'll be shake 30 seconds. Then we're gonna do this. It's called a massage. We're gonna do a massage on the surface of the tomato for 30 seconds. And then we shake it again for 30 seconds. The idea is dislodge bacteria from the surface. Okay, I prepared this sample for some of you. You guys can go ahead to use it. So this is what we will do. We'll do shake 30 seconds and massage 30 seconds and shake 30 seconds. So that is a tomato. Okay, that's how we prepare. The second thing, the hot dog. Or we say frankfurter, not sometimes we say. The risk for the pathogen is Listeria monocytogenes. That's related to outbreaks a lot. We'll talk about in the lecture. So the same thing. We're gonna add 1 hot dog into the bag. Okay? And then this time we dump a little bit more. We add 100 ml, 0.1% nutrient broth. So how are we gonna do? The tomato is right here. We're gonna get a hot dog. So we have another bag. The hot dog. By the way, hot dog, you should know this is a high fat products. It's not a safe product, not healthy products. High salt also. Okay, salt could be 10%, fat could be 15-20%, and there is antimicrobials. If you look at the label, it's called sodium diacetate, potassium lactate. And definitely, when you see the color, looks like a brownish color. It's a curing product, which means they have a sodium nitrate or nitrite there. Is that right? That's what we talk about in the lecture a little bit. So hot dog, how are we gonna do? We're gonna put 1 hot dog inside. We can put 2 hot dogs, but usually we put just 1 hot dog. Make sure they'll stay at the bottom. Okay, so we're gonna add 100 ml. So we add 100 ml. So once you have 100 ml, use cylinder to measure. You're gonna add inside. Okay. The process needs to be follow the USDA FSIS regulation. How we do? Hold on here. Couple rows. Then you have an air gap in there to hold on. You're gonna vigorously shake 30 seconds. That's the standard procedure. The air gap in the middle is let you to do a shake. Okay? So this method is rolling plus shake 30 seconds. So remember, what we are preparing is a sample, is a solution. That's number 2. Number 3, ground beef. Okay, ground beef looks like this. 73% lean, 27% fat. That's a high fat product also. The regulation, you should know, we mentioned a couple of times, this is 0 tolerance for E. coli 0157H7. And lots of the time what they do when they package it before they do a radiation finally. Okay? So ground beef, how are we gonna do? Ground beef, you cannot use these sampling bag. What happened? It will be basically homogenized, so you're not gonna get a solution. So ground beef, we need to use so-called smashed filter paper, the filter bag, like this. You can see there is a filter inside. How are we gonna do? Let's just wait 25 grams there. And then we're gonna dump in 100 ml, 0.1% nutrient loss. So what do we do? Approximately, okay, we don't have a scale. We're gonna get approximately 25. So how we do it? Tear it off. I did lots of years, so I know approximately this chunk is about 25 grams. So we're gonna add in, okay? And then we add 100 ml. So we add 100 ml. Okay. So we had 100 ml. What are we gonna do? You think we're gonna shake? No. You think we're gonna parboil it? How are we gonna do it? Is that right? You're not gonna homogenize it very well. So twist it a couple of times, and then look at what I do. The camera is moving, just directions go there. So what we do, this guy, you never notice it. It is important. That's $2,500 for homogenize. That's what we do. How long? We can adjust the time here, about 30 seconds. Okay, you can do homogenize, mixed very well, averagely with meat and the solution. Okay, let's say the time is ready. How are you gonna get the sample? You have two sides. One is meat, another one is solution. Squeeze like this, took from the solution side. See, it's very red. Why? Globin, microbial, is that right? So that's some of we talk about chemistry. Deoxymicroglobin, myoglobin, methmyoglobin, we talk about it. So that's for the ground beef. It's very interesting how we sample the ground beef. The different products is all the difference. Okay, so that's what I prepare here. You guys can use it. Okay, what we left? A chicken. A big chicken. Number 4 is a poultry carcasses. We just say chicken carcasses. We have a special talk. It will be next week or the following Thanksgiving in the lecture. We'll talk about the poultry microbial safety. Here we're going to talk about how we do the sampling. Poultry is large. So we do a poultry sampling bag. We put the birds there. The bag is huge like this. Because it's huge, okay? So how we do, we add the birds there. We're going to dump 200 ml, 0.1% nutrient broth. And then we do vigorously shake 30 seconds. So how we do it, this you may need 2 people work with you together. We're going to put the birds in. I'll show you how we do it. The birds have to be, make sure that this is opened. You have 2 people are working together, okay? So you go inside. We do this all the time. We have a birds project about Campylobacter and Salmonella. So we have to and you can see The bird, sometimes there is intestinal stuff there. So we have to take it out. You see there? Oh, this is neck there. We don't like it. We took it out. This is a commercialized samples with lots of water. But their solution is good because the blood is like our blood, agar blood. Nutrition will easy to let it be the enrichment. Okay, when you have this, we add 200 ml. So what we do, we add 200 ml. Okay, a little bit more. When you add that, how we do? Vigorously shake. And be careful about the wings, because the wings could block the bag. Have to be careful about the leg. Okay? So this will be a bird sample for some of you to process. If you like the chicken, you can take it to the home. Okay, it will be a Thanksgiving gift. I cannot do turkey, it's too large.
Are you serious?
Yes, you can take it to the home. After sample, because there's no bacteria. But the only thing what you do is you have to well down cooking. Okay? That's very important. You cannot eat raw chicken. Yeah, after you do, you can take it to the home. I always do that. Okay, not done yet. This is we prepare all the solution. So how are we going to do? Everybody will get 3 cubes like we did before. This is 9.9 ml, 0.1% nutrient loss. Okay, from all these solution, we say prepare the solution. We will add 0.1 ml, that means 100 microliter into the first one. And then we mix very well, add 0.1 ml, go to the second tube. This is also 9.9 ml. Then we add very well, goes last one, 0.1 ml, also 9.9 ml. So what's the dilution factor of the tube? 10 to the power of 2, 10 to the power of 4, and 10 to the power of 5. Okay, do we think it is too much? We can do like that. It may be too much. It's maybe too much. So we, sorry, 10 to 6. We basically what we do, we took this out. Okay, we don't do that one because the dilution is too much. We don't expect on the chicken there is more than 10 million bacteria. So we will keep these two. But how you do? You're gonna get original solution 0.1 ml onto the agar plates. Do the spread plating. That is 10 to the power of 1. Then you add 0.1 ml. Remember, this is 0.1 ml, okay, on the agar plates. This is 10 to the power of 3 spread plating. The last one, 0.1 ml onto the agar plates, spread plating. This is 10 to the power of 5. And this is give you averagely crossed, will cover the multiple dilution factors. So in case it's really lots of the bacteria, let's say ground beef, because ground beef, they cut the beef, then they ground it. There is more or less have a mild heat generally. That heat is usually 40 degrees Celsius. It's favorable for bacterial growth. Honestly, there is a higher nutrition there, and there is a blood there, there is a moisture there. So ground beef usually is very high. Okay? So that's what we're going to do. You prepare 2 tubes. Don't forget to grab from the original solution. Original solution for the tomato is just here. The original solution from the hot dog is just right here. The original solution from the ground beef is a little tricky because you have to squeeze it, okay? Otherwise, your pipettes will be stuck there. And the original solution from the chicken, you just get it from here. We don't want to waste, so these four I prepared, you can go ahead to do. Other students will be doing by yourself. Let's just do a pair for preparing the sample, but when you do serial dilution, everybody do individually, okay? Which means you share a one sample bag of the ground beef, but when you do the spread plating and dilution, you do individually, then you get a practice. If some of you really very interested to do individually, you're welcome to do an individual set. Okay, so that's all we have. And when we get a number, next week, Tuesday, we will talk about the calculation. The calculation will be in the final exam, that will be the tricky thing. Okay, so that's all we have. We'll have fun today to prepare all these samples.